Hello students, the question is, in the diagram given below, there are three lenses formed. Considering negligible thickness of each of them as compared to R1 and R2, that is the radius of curvature of upper and lower surfaces of the glass lens, the power of the combination is, and the given options are in terms of radius of curvature. So the situation is something like this, that there is a container having a glass lens, and both sides of this glass lens there are water surfaces, the water layers, and the water layers are also acting as lens. So we have to find out the combined power. Suppose we are showing the lenses formed like this. For example, this is the first lens. This is the first lens which is of water. The ray is coming from the upper surface like this. So this is the water lens. Then the second lens is made up of glass, which is like this. So this is the glass lens, and the third lens again is made up of water like this. So this is the water lens again, and we have to find out the combined power or the power equivalent. So power equivalent is basically the sum of the individual powers. It means that P1 plus P2 plus 3 P3. Suppose the power of first one is P1, power of second one is P2, and power of third one is P3. So the combined power is P1 plus P2 plus P3. And we know that the power is related to the focal length by P equals to 1 upon F. So P1 equals to 1 upon F1 plus 1 upon F2 plus 1 upon F3. So this is the total equivalent power. Now we know that the focal length formula for the lenses, to calculate the focal length for lenses, we have to use this formula. 1 upon f equals to mu L upon mu m minus 1 upon R1 minus 1 upon R2. We have to use this particular formula, and for each and every lens which is formed here, we have to use this formula, where mu L is the refractive index of the lens and mu m is the refractive index of the medium. So for the first lens that is made up of water, we have to use this formula. So first one, the first term here is mu L, that is the refractive index of the medium, and the refractive index of the medium, which is water in this case, is 4 upon 3. So we have to put 4 upon 3. Now to calculate the individual powers, we have to assume the surrounding medium to be air or vacuum in this case. In for every lens, we have to take surrounding medium as air, and we know that the refractive index is 1. So 4 upon 3 upon 1 minus 1 upon R1. Now here the radius of curvature of this plane surface, the plane surface on which the rays incident first. So since this is plane, the radius of curvature is infinite. So 1 upon infinite minus 1 upon the curved surface of the water lens, the first water lens which is forming the curved surface. We know this curve is basically coinciding with the inner curve of the glass lens, and the radius of curvature of this side of the glass lens is having a value of R1. So that's why we have to use R1, but the direction of incident ray is opposite to the direction of radius of curvature of this water lens. So that's why we have to use minus R1. Now for the power calculation of the second lens, which is water in this case, which is glass in this case. So for glass, we have to use the lens medium as the glass material having a refractive index of 3 by 2. So 3 by 2 upon 1 minus 1. Now the inner side, this inner side of this glass lens is having a radius of R1, and the direction is opposite to the direction of the incident light. So that's why we have to use 1 upon minus R1. Then minus sign 1 upon the radius of curvature of this outer side of this glass lens, which is R2, and again the direction is opposite to the direction of incident light. So that's why we have to use minus R2. Then plus 1 upon F3, which means that the refractive index of the, which means that the formula for the water lens. So 1 upon F3 is equal to mu L, which is 4 upon 3 upon 1 minus 1 upon. Now here the radius of curvature of the this inner side of this water lens is R2, and again the direction is opposite to the direction of incident light, so minus R2, then minus 1 upon this second side of this water lens is plane. So that's why we have to use infinite here. So these are the respective values which we put in the formula, and after calculation we found the result to be 1 upon 6 bracket 1 upon R2 minus 1 upon R1. And if we see the different options, option 2 is matching this. So this is the answer. तो यहाँ एक प्रॉब्लम पूछी गई है रे ऑप्टिक्स की, इसमें 3 लेंसेज जो हैं फॉर्म हो रहे हैं, 2 जो हैं लेंसेज वो वाटर से फॉर्म हो रहे हैं और एक लेंस ग्लास से फॉर्म हो रहा है। हमें कंबाइंड पावर निकालनी है इस कॉम्बिनेशन की। तो कंबाइंड पावर होगी P1 प्लस P2 प्लस P3 जो बराबर होगी 1 अपॉन F1 प्लस 1 अपॉन F2 प्लस 1 अपॉन F3। यहाँ फॉर्मूला हम लगाएंगे 1 अपॉन F इक्वल्स टू म्यू एल अपॉन म्यू एम माइनस 1 ब्रैकेट 1 अपॉन R1 माइनस 1 अपॉन R2। म्यू एल जो है लेंस का रिफ्रैक्टिव इंडेक्स, म्यू एम मीडियम का रिफ्रैक्टिव इंडेक्स। इंपॉर्टेंट पॉइंट यहाँ ये ध्यान रखना है कि इंडिविजुअली जो हम ये कैलकुलेशंस करेंगे उनमें हम सराउंडिंग मीडियम को एयर लेते हुए चलेंगे। तो इस तरह से हमने सारी वैल्यूज पुट करी विद द प्रॉपर साइन कन्वेंशन। तो हमारा जो फाइनल रिजल्ट आता है वो आता है 1/6 1/R2 माइनस 1/R1। तो इस तरह से हम कहेंगे ऑप्शन 2 जो है हमारा करेक्ट ऑप्शन होगा। सो दिस इज द राइट आंसर। सो होप यू अंडरस्टैंड द एक्सप्लेनेशन। थैंक यू।